All right, so chapter 6 is all about simplifying different types of radicals. You guys are most familiar with square roots, but today we're going to talk about the cube root, fourth root, fifth root, sixth root, so on and so forth, and how to simplify those types of problems. So make sure you have your calculator. We're just going to go through some vocabulary here first on page 1. So we know that 5 squared is 25. So we can say that 5 is a square root of 25. 5 cubed is 125. So we say that 5 is a cube root of 125. We know that 5 to the 4th, if you're not sure what that is, just put that in your calculator. Remember to get exponents other than 2. You just hit the caret symbol, which is above the division sign on the calculator. And it will give you 625. So 5 is a fourth root. And then 5 to the 5th, again, put that in your calculator, 3,125, so we say 5 is a fifth root. Just meaning, like, for example, if I take the square root of 25, I get the answer of 5. If I take the cubic root of 125, I get an answer of 5. Okay, that's what I mean by square root, cubic root, fourth root, fifth root. Okay, so let's jump down below and do some vocabulary here, and then we'll come back to the middle. You guys know this symbol as the square root symbol, but that's only whenever we're working with problems that have an index of 2. Okay, so this symbol, we're going to now start referring to it as the radical. Whatever's inside the radical, that's called the radicand. Okay. Now the most important part here is we're going to start seeing little numbers out here, which we've kind of seen with the cubic roots already. But those little numbers, those are called the index. Okay, so when I refer to the index, I'm referring to that little number on the outside, and that just tells us what kind of root we are taking. So for example, if we take the cubic root, that means there's a little 3 there. The fourth root would have a 4. The fifth root, so on and so forth. Okay, it's different from having a big number outside. Like, for example, this is 3 times the square root of 2. That's different. This 3 here, that's multiplication. That's not the index. The index is always a little number. So something to note here, guys, the square root technically has an index of 2, but you're never going to see that written. Okay, so think about like your variables. When we talk about x squared, x cubed, if I just list x is like the smallest you can go. It's to the first power, but we never write the 1. Same with square roots. The square root is like the smallest you can go. We never write a 2. Okay, so you'll never see a 2 out there. If there's no number, then it's just the square root. Okay, if there's no index, it's just the square root. When a number has 2 real roots, the positive root is called the principal root. So all that means is if you get an answer like plus or minus 5, if the directions say to just give the principal root, All they want is that positive 5 as the answer. Okay, so now let's go ahead and go up to the middle here. So the definition, it says for any real number a and b and any positive integer n, if a to the n equals b, then a is the 9th root of b. So that's basically just what we were going over up top here with these 4 examples. Okay, so now this box talks about the types of answers you're going to have. And how many. So it says the first column, number type, positive, 0, and negative. The second column says number real roots when n is even. So we're talking about when the index is even. So for example, if we have like the square root, the 4th root, the 6th root, if the inside is a positive number, so for example, the square root of 25, you guys know that the square root of 25 is plus or minus 5. So therefore, I get 2 real answers. Remember, it's plus or minus 5 because we know that 5 times 5 gives us a positive 25. But also negative 5 times negative 5 gives us 25. So we don't know how this 25 was created. That's why you have to make sure you assume that it could be a positive 5 that created it or a negative 5. That's why we have 2 answers. If I do the square root of 0, what's the square root of 0? 0. So you get 1 real answer. There's no such thing as plus or minus 0. It's just a 0. And then if we get a negative number inside, like negative 25, you guys know that that negative inside makes no real solutions, but it does make our imaginary solutions. So we would get 2 imaginary answers. Okay, so that holds true whether we have a square root, whether we have a 4th root, a 6th root, anything that has an even index. So now let's look at some examples where we have an odd index. So for example, cubic root, 5th root, 7th root, so on and so forth. Okay, so for example, if we have a cubic root of 27, when you put that in your calculator, remember how to get there. You hit math, number 4, type in 27. It's going to give you 3 as an answer. So for this one, guys, you only get 1 real answer. There is no plus or minus on this one because if you think about it, in order to create 27 by multiplying the same number 3 times, it's got to be a positive 3, right? Because 3 times 3 times 3 is 27. If we also say it's negative 3, that's not correct because a negative times another negative would be a negative answer. So that's why there's only one real answer. Cubic root of 0, put that in your calculator. And that's 0, so you get one real answer. And then this one's probably the most surprising one. When you do the cubic root of a negative number, put that in your calculator. That one gives you a -3. It doesn't give you an error like the square root of a negative would, right? Because that's imaginary. You can actually have negatives inside radicals that have odd indexes, okay? Because again, think of this example here. -3 times -3 times -3 is what allows us to get to -27. So you have one real answer. Okay, so let's go down and just do some practice with the calculator. Go ahead, take a minute here. Find the cube root of 27.008 and then 1,000. You should get 3.02 -10. The fourth root, we're going to skip this middle one because anytime you're working with negative numbers inside of radicals that are not square roots, the imaginary numbers work a little bit differently. It's a little bit more complex than what we have with square roots and negatives. So we'll skip that one. Okay, so to do the fourth root in your calculator, when you hit math, you'll notice number 5. I'm going off memory here, but I believe it something like that. So that just allows you to put any number you want in as the index. So when you hit math number 5, you should type a 4 in, and it will go as the tiny number as the index, radical symbol, and then put whatever number you want. So go ahead and do those two examples. Okay, fourth root of 0 is 0. We don't need a plus or minus on there because, again, it doesn't make sense to have a positive or negative 0. Fourth root of 16/81, if you got a decimal, just hit math, enter, enter. You should get 2/3. And then because it's an even index, you need that plus minus. All right, so go ahead to the next page. This is our last page here. Go ahead and try those 3 problems for me, please. Okay, the cube root of -27 is -3. There's no plus or minus on that. It's an odd index. The fourth root of 81 is 3, but we need the plus minus on there. Even index. And then letter C, again, if you don't see a tiny number for the index, that just means it's the square root. So the square root of 49 is 7. And again, you need that plus minus. Okay, so even index, always use plus minus. Odd index, I always say nothing special. Okay, so if you take anything away from this lesson, it's knowing what I mean by the index. That's the most important vocabulary word from this lesson. Okay, so we have a property here, and I rewrote it in a way that I think makes a little bit more sense. So go ahead and read this and copy it down in your notes. I know it's a little bit more writing than usual, but go ahead and copy that. So when you have an even index, okay, so 2, 4, 6, and your answer, okay, so after you simplify whatever's inside, has odd exponents, you will need to use absolute values around that term. So let me give you an example of what I mean. So we're going to start simplifying variables. So if you look at this example here, I know my index is a 2 since nothing's written. The way we simplify these problems, it's actually very easy. You look at this as like a two-part problem. You're going to simplify x to the 6th, and then you're going to simplify y to the 8th. The way you do this is you look at the exponent here, and you divide it by the index. 6 divided by 2 is 3. So we write this as x cubed. And then we do the same thing for y. You take the exponent and you divide it by the index, which is 4. So y to the 4th. So exponent divided by the index. Okay, now it's an even index, so we need our plus minus. Now, because it's an even index, my answer has odd exponents. All right, which one's the odd exponent? X cubed. Therefore, you need absolute values around the x cubed. You don't need it around the y to the 4th because 4 is an even exponent. And the reason for this property is because the inside is x to the 6th, we know that whatever x is, when you raise it to the 6th power, when you raise it to an even number here, it's always going to give you a positive value, right? Like think about it. Negative 2 to the 4th. Put that in your calculator with parentheses. It gives you positive 16. If you do negative 3 squared, it gives you positive 9. Right? So when you raise it to an even power, it's always going to be positive. So we have to make sure that we keep that in check with our final answer, that this also needs to be positive. All right, so once again, odd exponent in my answer, I put absolute values. If it's not odd, you don't need it. And that's only for even indexes. All right, so let's try a few examples here. This one here, I have an index of 2. So as soon as I see an even index, guys, I put a little star to remind myself that there's a couple extra steps I have to take at the end, right? Plus, minus, absolute value bars. So look at this as a 3-part problem. We got to simplify the square root of 4, x squared, y to the 4th. So the square root of 4 is 2. The variables, again, I take the exponent and I divide it by the index to get 1. So it's just x to the 1st. Exponent divided by the index, I get 2. So it's y squared. Even index, so I need a plus minus, and then I need absolute values around the x to the 1st. It has an odd exponent. You don't ever need absolute values around the coefficients here because we're already considering that 2 to be a positive or negative, or both. All right, next one, I look at this one, I notice it's an odd index, so I'm kind of happy because that's less work I have to do at the end. So again, look at this as a 2-part problem. Simplify negative 27, simplify c to the 6th. Now it's the cube root though, so just be careful when you type that in your calculator for negative 27. All right, you're going to hit math. You could hit number 4 or number 5, really. Can't put variables in the calculator. Cube root of negative 27 is negative 3. And then we would do 6 divided by the index, get 2. So c squared. Next one here, it's an even index, so put a little star here to remember to do some extra work at the end. 8 divided by 4 is 2, so x squared. 12 divided by 4 is 3, so y cubed. Plus minus, absolute values around the odd exponent. Okay, let me give you 2 more examples because these notes only had problems where the index divided the exponent perfectly. So let's see some examples where that doesn't happen. So let's do the square root of x to the 10th, y to the 9th. Okay, so index here is a 2. So let's go ahead and go through here. 10 divided by 2 gives me 5. So that becomes x to the 5th. For the y, though, 9 divided by 2, well, that gives me 4, right? 2 goes into 9 4 whole times, but I have a remainder of 1. So what happens, guys, is we write the y to the 4th on the outside, but then the remainder stays inside the square root. So because it's a remainder of 1, it's y to the 1st. Okay, so again, however many times 2 went into 9, that was 4 whole times. This is what went on the outside with the y. The remainder is what stays inside the radical. Now it's an even index, so we have to put our plus minus absolute values around the x to the 5th. You don't need absolute values inside a radical symbol. All right, last one here. Let's do the square root of 32x to the 5th y squared. Okay, so index is a 2. So again, a little bit of extra work at the end. Look at this as 3 parts. Now we should be pretty good at simplifying square roots since you guys have been doing this for a while with our quadratic formula. But square root of 32 is not a perfect square. So yeah, unfortunately this is not going away. You have to know those perfect squares. So find the largest that divides 32. 16. Right, so that's 16 times 2. So the 16 comes out as a 4. Now I like to leave some room here because I know I'm going to have some variables next to that 4. So I'll move my square root of 2 away a little bit. Then we do the variables. 5 divided by 2, that's 2 whole times with a remainder of 1. So that's x squared on the outside, remainder of 1, so x to the 1st on the inside. And then your y value, 2 over 2 is just 1, so that's y to the 1st on the inside. No y's are left. I'm sorry, y to the 1st on the outside, no y's are left on the inside. Okay, and you don't have to write these ones here. I'm just trying to make sure you're able to follow along with my work. Again, don't circle and rejoice yet because it's an even index, so you need your plus minus, and then we need absolute values around the y to the 1st. All right, so last problem here is your real world example problem, so you can understand where this is used outside of the classroom. So go ahead and read that paragraph, please. All right, so we're talking about shipping a carton of oranges. We know that an orange weighs from 8 to 9 ounces, and each carton can hold 3 dozen oranges. So it says in 3 layers of 3 oranges by 4 oranges. So if you just look at this picture here, we can tell that the oranges, we have 3 high, 3 deep, and then it looks like 4 across, or length. So basically what we need to do is figure out what the diameter is of one of these oranges. So then that will help us figure out how much space we need to fit 4 oranges across, 3 oranges deep, and 3 oranges high. So if you look at the formula they gave us, it says the weight of an orange is related to its diameter by the formula W equals D cubed over 4. So to find the weight of one orange, all you do is take the diameter, cube it, and then divide it by 4. Now that's important to know because What we really need is to figure out what the diameter is of an orange. So what we can do is take this statement here that an orange weighs between 8 and 9 ounces, right? That deals with weight. So we're actually working with a compound inequality. We can take our weight formula, and that's going to go in the middle, right? Because we know the weight has to be between 8 and 9 ounces. And now we solve this. So hopefully you remember how to solve a compound inequality. Get rid of that fraction that's in the middle, so multiply by the denominator, and then far right, far left. Now we need to get d by itself. So how do you get rid of something that is to the third power? You take the cubed root of it. Now because we're working with measurements and box sizes, you're not going to give your answer in radical form. You would probably put that as a decimal. So I'm just going to go to the nearest hundredth here in my calculator. That's about 3.17, less than or equal to d, less than or equal to 3.3. And we're talking about inches. Okay, so this means that the diameter of one orange is between 3.17 inches and 3.3 inches. So now that we know the diameter of one orange, we can find the diameter of 3 oranges and 4 oranges. Now obviously if you're packing these up in a box, you want to err on the side of caution and go with the bigger measurement, because if you go with the smaller one, then there's a chance all the oranges wouldn't fit. So we're just going to go ahead and assume each orange has a diameter of 3.3 inches. Okay, so if I go ahead and figure this out, to figure out the length of my box, there's 4 oranges, so 4 times 3.3. The depth of the box needs to be 3 times 3.3. And then the height of my box needs to be 3 times 3.3. Again, this 4, this 3 just comes from this image here. So that's about 13.2, 9.9, and then 9.9. It says cartons can be ordered in whole inch dimensions. Okay, so again, we're going to be rounding up no matter what, because we don't want to round down or you might make your box too small. So we would say you need to order a box that is 14 by 10 by 10 inches. Okay, that's how you use this in the real world, shipping oranges. All right, that's it for section 6.